On the screen is a timer file. This is a demonstration of timers. We're coming out of the data files. Data files, T4 is a timer. Timer works just like a counter. It consumes or uses three words, three 16-bit values. One 16-bit value for the accumulator, one 16-bit value for the preset. The other 16-bit value operates the control points. You have enabled, timer timing, and done. Enable bit turns on anytime the timer is activated. Timer timing bit is activated anytime the timer is actively counting. The done bit, this will activate when the timer has reached its preset and is done counting. Now time bases can change. If I come over to the time base, we got a choice. 1 second, hundreds of seconds, milliseconds. So most different types of programs will give you a choice in the different types of counts. Now right here on the tab, the timers come over here on the timer tab. We can time on, time off, and retentative time on. Well, the time on and time off will reset themselves when you lose logic in front of the timer. The retentative timer is going to require a reset instruction. It'll have to be reset. Top line, line 0, we have a start-stop station. And I'm using the output as a master control to turn the circuits off. Now right here on this first line we have a time on timer. This timer right there, timer 40, time base 1.0, 1 second, preset is 10 seconds. Now right here, this bit right here is going to reset the timer. When this done bit activates, this contact will open, resetting the timer. Line 2, I basically have the same structure. Time on timer, T41 times out in hundredths of seconds. So this timer is going to count out to the count of 100. Once it reaches that count, the done bit is going to open. Then we have milliseconds. T42, time-based milliseconds, 1,000 milliseconds. When this timer is a time-off timer, so when it turns off, it's going to actually open up and dump the logic. Well, it will restart the logic. Time on timer, it times when it receives logic. Time off timer times when it loses logic. Time on timer times when the time on timer turns the done bit on. Time off timer turns the done bit off. Now right here we have some outputs. As timer 41 becomes enabled, the output turns on. Timer 41, as it times, the output is on. Timer 41, when the done bit activates, it's going to pass through what's called a one-shot, and it's going to turn the output on. Well, the one-shot only allows one scan to pass through, only one scan. If you push a button or a relay activates in the period of time that contact makes and breaks, it can pass several thousand scans. So this is a time frame that only allows one scan to pass. Now to activate this, let's run this program by downloading it. I go ahead and download. Processors in run mode. We do not apply loss of communications. We go back to run mode. We go online. Well, top line, I push the start push button. Well, turn on the stop button, my stop switch. Push my start button and it latches and activates. As we look at the counts right here, we have the first timer is counting T40 in terms of seconds. Every time it reaches the 10-second mark, for one scan, this done bit's going to open for one scan, which is typically about 1/100th of a second. Now this next timer right here, T4-1, is timing out in tenths of seconds. So it's timing out basically at 1 second intervals. And again, that done bit is opening for one scan, and that done bit is going to reset that timer. Here again we have 1,000th milliseconds, T4-2. That timer's counting right there, resetting itself about once every second. We have the enable bit that turns on anytime the timer 4-1 is activated. Bit turns on timer timing anytime the timer's active timing. These two bits are actually shutting off for only one scan. Then the last load right there, this done bit is actually closed for one scan, and this output is only on for one scan. So much faster than the computer monitors can keep up with. So timers can be used, we could use any point of that timer as control, including the accumulator can be used as a control. So we can use it to time frames, we can use it to control equipment, set up time frames for anything we need. We can turn the done bit on, we can turn the done bit off. We can activate while the timer is actually timing. There's a lot of control points, and timers are very common in industry. Very common. Another timer that's commonly found is what's called a retentive time-on timer. Okay, retentive. It's a time-on timer that retains its count. It'll retain its count. Now, right here we have the start-stop station to power it up. We have our logic that turns it on directly from the start-stop station. As this timer runs, it becomes enabled. The enabled bit will close, turn it on the load. As this timer times, T40 right here will close. And this bit will only close while the timer actively times. Turn it on the load. Once the timer is done timing, the done bit turns on, turning on the output. This timer requires a reset. No matter what the state of logic is in front of it, it will retain its count until it gets a command to reset. So a different type of timer, and again very commonly found. So we download the timer. When I download it, we are erasing the memory and replacing. We go back to run mode. We go online. And again, I go ahead and start the circuit up. Stop button, start button. And my buttons are rearranged on the top. But as that works right there, look at the timer right there on the time. The timer itself. It counts in seconds. If I drop the logic in front of it, it doesn't reset. As I drop the logic in front of it, right there, that accumulator maintains its count. The timer timing bit is now off. The enabled bit is now off. We activate it again. Enable bit turns on, timer timing turns on. Once it reaches the preset, the timer timing bit turns off and the done bit turned on. Right here, done bit activated. It's no longer actively timing, yet it is still enabled. If I drop the logic in front of it, it does not reset. So this timer is going to require a reset instruction. As I push that reset instruction, that'll reset that timer. So that accumulator will go back to 0. Once that's activated, the reset is activated, the accumulator goes back to 0. So So if I go ahead and start the timer, it times, it's activated, it's timer timing, the done bit is not activated, but I can reset that timer at any time. So this timer right there could be set up as a clock. It can count virtually anything, and it maintains its count. This is called retentive time on. Retentive time on.